So we're now going to talk about the formal definition of the limits. And let's be a little bit careful here. So there's one formality, let's say, that we need to discuss first. So basically what we want when we discuss the limit, we want to discuss the two-sided limit. So this means we need for x to be able to approach a from two sides. So when we look at some interval, for instance, the interval from, well, between these 2 points, whatever they are, we call this and this the endpoints, and everything in between the inner points. Okay. So if, for instance, a is now an endpoint of the interval where f is defined, we can only approach from one side, right? From the right, if a is here, or from the left, if a is here. Now, if a is an inner point, we can approach from both sides. So naively, what we would want in order to consider this expression is for a to be inner point of df. Now, another way of formulating this is to say that f is defined on a neighborhood of a. Okay, this is actually this sounds a bit weird maybe, but this really just means that f is defined at a and then at least on some interval stretching out to the left and to the right from a. So if a is here and we have a little bit of wiggle room here and here, then f is defined on a neighborhood. Now this is too strict because remember we want to consider limits of this form here. X goes to, well, let's do 0. And here you have an f of x. And remember, we saw in an earlier film that this ought to be 1. We haven't proved this, but this ought to be 1. And the point here was we really wanted to study a function point that was not in its domain. So this thing here is way too strict. We don't want to require a to be in the domain of f, much less to be an inner point of the domain of f. But we still want this wiggle room. So what do we do? Well, what we say is that if this now is the domain of f, we want a to sort of be in the domain, but we allow for the domain to skip the point a, so that the domain comes from this side and then ends in an open interval here, and then continues like this. So basically what we want is to be able to express that our domain is of the form, let's call it C0 up to a, but not including a, and then continuing like this up to some C1. So what word would we use this? Well, the word we would use here that we would add is that a is defined on a punctured neighborhood of a, which means exactly that intervals of this form is contained here. And if we look at this example here, then f of x equals to sine x divided by x has df equal to r take away 0, which is the same as going from minus infinity to 0, and then from 0 to infinity. So this guy is defined on a punctured neighborhood of 0. And of course, this means up here I'm putting a closed, so I really don't care if this is open here or closed here, or if these c's are finite or infinite. All I care is that this is strictly less than a, and that this thing here is strictly bigger than a. So this was a preparation before we define what this means.